Chapter 12, Part 1, on Liquids, Solids, and Gases. The various states of matter, gas, liquid, and solid, can be pictured as follows. We have the gaseous state, in which the molecules are far apart and they're in rapid random motion. They fill the container, they do not have a definite volume or shape. The liquid state, the molecules are fairly close together, and they're in random motion, and they can slip and slide over one another. And they occupy a definite volume, but they can take the shape of the container. And finally, we have the solid state, in which the molecules are close together, but they only have a vibration motion, and so they stay in their position but vibrate. They have a definite volume and shape. Here's just a look of the liquid state in another shape of container. They have the shape, they assume the shape of the container, and they have a definite volume. Solids, for instance, this is the edge of an iceberg. It has a definite shape and volume because the molecules are locked together and they can only have vibration motion. What is evaporation? Well, because the molecules on the surface of the liquid are less tightly held, they're attracted to the molecules below, but they have nothing above than those that are in the interior, which are attracted on all sides. If you produce enough energy, they can break away and escape as the gaseous state. This is called evaporation. In evaporation, substance converted from the liquid state to the gaseous state. The evaporation and condensation, which is the reverse of evaporation, involves energy changes. The rate of evaporation will increase if you have increased the surface area, or if you increase the temperature, and if you happen to have a substance with very weak intermolecular forces. Liquids that evaporate easily are called volatile, and those that do not vaporize, these are called non-volatile. During boiling, thermal energy is enough to cause the water molecules in the interior of the liquid to form bubbles containing gaseous water molecules. And so the bubbles filled with gaseous water rise to the surface. And that's what you see when something is boiling. Let's look at a heating curve. That is where you start with a substance, in this case a liquid, at about 20 degrees Celsius, and you add heat. And it slowly warms up, 20, 40. It warms up kind of at a constant rate depending on its specific heat. That's the amount of energy needed to raise 1 gram of the substance 1 degree Celsius. So it's warming up steadily, and this is water, till it gets to 100 degrees, and then you keep adding heat, but all the heat goes into the substance, causing the liquid to break apart the intermolecular bottles and bounds and become a gas. So all the time that it's being transported from a liquid to a gas, you have constant temperature, and that's boiling. And finally, when you get just steam, again the temperature of the steam can be increased by adding more heat, more energy and motion to the molecules. Evaporation is endothermic. When a liquid is converted to a gas, it absorbs heat. Heat is taken into it because the energy is required to break the molecules away from the rest of the liquid. Our bodies use endothermic nature of evaporation for cooling. When we overheat, we sweat, causing our skin to be covered with liquid water, and then that evaporates, and it takes heat from the body, makes us feel cooler. High humidity slows down evaporation, so when it's very humid, evaporation doesn't occur as readily, and our cooling system of evaporating sweat is less effective. Energy of condensation, that is going from a vapor to a liquid. Condensation is exothermic. meaning that as something condenses, it gives heat away. It's released, such as when a gas condenses to a liquid. As steam condenses to a liquid in your skin, it can really cause a very, very bad burn because the heat then is transferred to your skin. The exothermic nature of condensation also is the reason that winter overnight temperatures in coastal cities, they tend to have water vapor in them, and they do not get as low as in deserts, where they tend to have dry air. As the temperature in coastal city drops, the water condenses out of the air, releasing heat and preventing the temperature from dropping further. In desert, there's little moisture in the air to condense, so the temperature drop is greater in the desert. Melting and freezing. Melting is sometimes called fusion. As the temperature of a solid increases, thermal energy causes the molecules to that the stuff is composed of in the solid to vibrate faster. And at the melting point, the atoms and molecules have enough thermal energy to overcome the intermolecular forces that hold them at their stationary points, and the solid turns into a liquid. A way to cool down a cold drink is to drop several ice cubes in it. As the ice melts, the ice takes in heat from the drink to do the melting, and the drink cools because melting is endothermic. Melting is endothermic because energy is required to partially overcome the attractions in the solid state so that it can move into the liquid state. Freezing now is exothermic. Heat is released when a liquid freezes into a solid. This is sometimes used in Florida by fruit growers to prevent freezing of fruit by spraying it with water. As water in your freezer turns to ice, it releases heat, which must be removed by the refrigeration system of the freezer. Sublimation. Sublimation is a physical change from which a substance changes from its solid state directly to its gaseous state, not passing through a liquid state. When a substance sublimes, molecules leave the surface of the solid, where they are held less tightly than in the interior, and become gaseous. Dry ice is a solid carbon dioxide, and it doesn't melt under atmospheric pressure at any temperature. It only evaporates by sublimation. At minus 78 degrees Celsius, the carbon dioxide molecules have enough energy to leave the surface of the dry ice and become a gas. Iodine is another substance that sublimes. And here's a picture of iodine, solid state, and it goes directly to the gaseous state, and then there's some ice surface up there, and you can see the iodine solid state accumulating at the top. And here's another picture of dry ice, which doesn't form a liquid, it merely just goes to the gaseous state. Sublimation. Ice sublimes out of frozen foods. You can see this in a food that has been frozen in an airtight plastic bag for a long time. The ice crystals that form in the bag are water that is sublimed out of the food and redeposited on the surface of the bag. Food that has remained frozen for too long becomes dried out. This can be avoided by freezing foods to colder temperatures, called deep freezing, and the colder temperature lowers the rate of sublimation, preserves the food longer. Here's a picture of the inside of an ice compartment. In this, you can see that this ice sublimed up onto the surface. In summary, it's about changes of state, and these are physical changes, not chemical changes. The state of matter depends upon the strength of the intermolecular forces and the energy in the motion of the molecules. Putting heat into a process is called endothermic, while heat coming out of a process is exothermic. The states of matter, solid, liquid, and gas, can be understood in terms of molecules.